the MVP Summit, and Greg asked us, hey, I have this user group. Is there something you can share? We said, well, we have sessions prepared for like in 2 weeks. And since we always prepare well in advance.
Basically, Kim, you're saying this is the beta test.
So this was done. And we actually have 3 sessions at MS that have basically been built upon request from people in the community that had questions. And we've said, well, we need to come up with a topic anyway. Let's cover something that we've been doing for quite a number of years by now. We've done quite a bit of Windows Defender application control work, and we often get the question from people that typically have some experience with AppLocker or have heard about AppLocker that say, yeah, but Windows Defender application control is hard. And basically insinuating AppLocker is not. Which to us was always a strange conversation or a strange thing to hear, because they're similar technologies. You can basically achieve the same thing. So what we're going to do today is we're going to build the minimal AppLocker implementation that we most often see, and which is the one that Adam asked about many months ago, which is why I basically strike down the date when Adam asked about this and when I finally came up with an answer to his question in a session. So without for the AppLocker admin /Adam is what our session will be today.
So quick comment. Everybody knows AppLocker or roughly uses it?
Which of those two?
And most users and nobody needs less. And then WDAC heard from it, uses it, probably nobody.
Oh, wait, you had a remark on?
Just because they were just starting to roll out AppLocker.
Okay.
Yeah. Oh, then it's going to be really interesting.
Yeah, it's been interesting already. Yeah, I'm part of the pilot.
So we're Kim, Tom, both from Belgium. We're here for the MVP Summit, and we're going to go to MS to present on. We both work for OSCC, which Kim owns, so he's basically my boss in some way and form. But we've been friends since college. And that's kind of important. We have been friends since college, because it might look like we hate each other and cannot stand each other, but that's not most of the time. Most of the time.
It's a bit of that. And as you can see, one of the policies within OSCC is that you get to pick your own title, your own job title. So that's the extraordinary consultant.
Funny thing is, he picked that one for me.
And don't forget to follow on Twitter.
Right, and don't forget to follow on Twitter. And you can email Kim if you want to. You'll never get an answer, but yes, you can. So, Kim already said a bit about it. We are gonna talk about AppLocker and the default AppLocker implementation that we most commonly see, and then how to replicate that into WDAC. This is not gonna be a deep dive in how WDAC works. This is not gonna be a full implementation guide. It's just gonna show you the similarities or differences between the two and how that evolves over time. We are going to talk about a few things. First of all, Kim did a lot of work in trying to measure how effective your AppLocker setup is. So he's going to explain how he did that. Now we're going to see what the minimal AppLocker implementation looks like, how we can replicate that in WDAC, how you can migrate from AppLocker to WDAC, and finally, why would you want to do that migration if the end result is the same? Spoiler alert, it's not going to be the same. So there is definitely some benefits in doing that. So the first one is measuring the allow listing effectiveness.
Because you have AppLocker, you have WDAC, and you have different configurations of each and every one of those. Right? So we were trying to come up with good policy suggestions for our customers. good policy advice on, okay, do this, don't do that, do this, maybe do that. Right? And one of the problems with that is all of it is like, okay, so what protects me better? Right? If I make certain choices, what's the impact on my attack surface? Because obviously, the more rules you create, the more you open yourself up to attack surface, meaning potential vulnerabilities, meaning potential threat campaigns. So we're looking for a way in measuring actual impact of those changes. Right, so that you could make a more informed decision on, do I want to allow this or don't I want to allow this? All right. And I basically built an Excel with, I believe, 8 or 9 different forms of implementing app allow listing across app locker through WDAC. Right. And then we looked at, okay, so what is called the threat landscape out there? What are the malicious folks trying to do? Right? What is that threat landscape? And how do the different implementations affect that threat landscape? So what you're seeing here is the different types of implementations. And do not try to read that. We have a slide where the actual implementations are spelled out more. And on the left-hand side, we have threat campaigns. Okay? So who in this room knows about Defender for Endpoint? So Defender for
Presentation after that.
Yes, presentation after that, indeed. Defender for Endpoint is Microsoft Endpoint Detection and Response solution, where they basically state, look, these are the actual threat campaigns with all of the customers that we see. This is what the malicious people are trying to do towards our customers. Right? This is the actual threats, the actual hacks that we see passing by. Right? So what I've been doing for quite a number of months is every one of those threat campaigns in Defender for Endpoint is actually described by a threat analyst. Right? So a Microsoft security person looks at this threat and tries to figure out, okay, so what are they effectively trying to do? What techniques do they use? And I've used those threat analyst reports and started reading them. And I basically go over every individual threat campaign and I verify for each and every one of the implementations that we track, whether it would stop, or not stop, or stop that particular threat campaign. Right? So if one of the campaigns has a 0 in it, that means that particular implementation of app allow listing would not stop this particular threat. Right? Vice versa, if a column contains a 1, then this particular type of implementation of app allow listing will stop that particular threat. Right? So we've been doing that for all of the threat campaigns since January 2022. Right? I still need to work back to like the end of 2019 when they started to build those threat campaigns, but we already have it for well over a year. Right? And that's what we use to basically measure how effective each and every one of these implementations is. Right? If we say this campaign would not be stopped by this particular implementation, it's a 0. If it is blocked, it gets a 1. People on the front row, probably not visible in the back, might notice that there are some -1s. -1 can mean a number of things. It often means it's not targeting Windows. So if you're targeting in your threat campaign Mac OS, well, yeah, Windows app allow listing technologies are not going to stop that. Right? So we basically take them out of the equation. There's a number of threat analyst reports that are not detailed enough. A lot of them are extremely detailed, but some of them are just not detailed enough for us to make an actual assessment. We take them out of the equation because I can say yes, no, I basically do not know. There's a third reason why we put campaigns on -1, and that's when no code execution is involved on the client device. A lot of campaigns nowadays are credential phishing campaigns. I send you an email to a fake website. If you enter your password credentials in there, I've basically stolen your password credentials. That's not something App Allow Listing can solve. You're not executing code on the client system. I have no way of blocking that. You'll have to look at other technologies to block that. So again, we take them out of the equation. Next. Yep. So this is a graphic of one of those App Allow Listing threat analyst reports, or Defender for Endpoint threat analyst reports. As you can see, often it's fairly graphical. There's a bunch that are just text, which are more annoying for me to analyze, but some of them have actually very good drawings. Okay. Another important thing to know is that a lot of the threat campaigns nowadays have a phase that is called hands-on keyboard. That basically means the malicious actor has achieved entry into your device. Right? They basically have the ability to start manually typing. They basically have a session on your device. Right? If we find in the campaign where the hands-on keyboard section starts, right, we no longer take into the equation which type of app locker collection that you have enabled. If you haven't enabled them all, right, we'll say it's an app locker bypass. Right? Because if I have hands-on keyboard and I'm a malicious person with quite a bit of knowledge, if you're only blocking executables, okay, I'll do all of my work in PowerShell. You've just had a PowerShell session. There's plenty of attack tools written in PowerShell. The fact that you're blocking an exe is mildly annoying for me if my tool is in an executable format, but I'll just translate it into PowerShell. Right? If you're only blocking exes and PowerShell, again, if I'm a malicious person, I have access to your device and I know what I'm doing, I'll write a DLL that does the exact same thing. Right? So once we hit the hands-on keyboard stage, if you're not blocking everything across the board, if you haven't enabled all of the rule collections, we'll mark it as a bug. Right? If you do not block all of these things. Right? That's me.
So what are the different setups that we have been talking about? So that was the columns. This side is AppLocker, that side is WDAC. Basically, what we see most often is the default AppLocker rule set, which just blocks executables from, or not allowed executables from being executed. And then you can increase the way that AppLocker blocks more and more things by enabling scripts, by that you start blocking scripts. If you want to go more secure, you can enable DLL blocking. And then if you want to go more secure, you just make the combination of exe, DLL, and scripts. So enabling each of those additional features in AppLocker will give you a better, each time a better security overview against all of those threat campaigns that Kim was talking about.
And we know that there's another rule collection for packaged apps and AppX. We just haven't seen any exploits, so we're not actively tracking that at all.
The other side is WDAC, where most of the people here are config manager. That means if you use config manager to deploy W or enable WDAC, the default option is actually the most secure, where the default option in AppLocker is the least secure. So in WDAC, you start the other way around, and then you can start adding rules that will decrease your security posture by adding path rules. Then first of all, for just program files and program files x86, enabling program files and windows, disabling scripts because WDAC by default blocks script execution, and then by enabling all the path rules and disabling scripts. So you notice there is nothing about DLLs because that's also a default in WDAC. WDAC by default blocks basically everything that is executable. DLL actually doesn't really matter. So that brings us to what is according to us, or what do we see the most in a minimal app blocker implementation?
All right, so what we see in a minimal app blocker implementation.
Or a default, yeah.
No, it's not necessarily default, it's something that we see often. There's no real default, you just choose which rule collections you enable. But we've never seen exit rules not being enabled, because that would not make a whole lot of sense. All right. So we typically see the exit rule collection allowed. All right. And then we see the default rules that you do get in every rule collections, which for app blocker means all admin executions are allowed. If you're a local admin, basically the app blocker rules do not apply to you. Again, you delete those rules and make them apply, but by default, they do not. And there's the default path rules that you've seen us mimic on the Windows Defender application control side, being program files x86 Windows. That's basically an app blocker implementation. There's an unfortunate portion in app blocker implementations, as far as we are concerned, around DLLs, where if you enable DLLs, you have to do it on an interface that says, be careful, be cautious. This might have a serious performance impact. And keep in mind, app blocker was written, and that page was written 12 years ago. App blocker can pretty much validate DLLs by now without you noticing any performance impact. But one of the reasons we often see it turned down is that exact page. We can tell people all we want that no, there will not be a performance penalty. We'll always have somebody that says, Microsoft appears to disagree with what you say. Okay, so people leave DLL rule collections disabled. We'll have a slide further down as to why that's probably a bad idea and how easy it is to bypass your app blocker implementation if you do not block DLLs. And we'll see what the impact is in the threat campaigns by not blocking DLLs.
Well, we actually have
Okay, a number. Okay. No, we don't have a number here. Yeah, but we're not showing it here.
We are.
Okay, we're not showing it here. We'll get back to this. Okay, so that's the minimal app blocker implementation. All right, so it's largely path rule based. That's largely your starting point. If you go to a default WDAC implementation, because you get some default sample policies, it is somewhat different. Okay? You obviously have exit rules that are blocked, right? But it's not bad based, it's actually based on a bunch of Microsoft publisher rules. Right? So WDAC doesn't say, I trust everything in Windows program files and program files x86. WDAC starts with, I trust everything that is installed on a freshly installed operating system. That's how WDAC starts. Right? And they do that because everything that is installed on a freshly installed operating system is signed with Microsoft code signing certificates. Right? And they trust a number of specific Microsoft code signing certificates that are used to sign operating system binaries. That's how WDAC starts out. And since it's based on signature, it's not just for the exit rule collection. They immediately do the same thing for all of their DLLs, and they basically enable script enforcement as well. Right? Which means if you want to run scripts, your scripts have to be defined in your policy as well. If not, they'll either not run, or they'll run in a limited mode which probably means they cannot do what you want them to do. Okay, so that's the difference. Default path rules, WDAC does not come with default path rules. So program files x86, if you have applications that you install, you'll have to make them trusted somehow. Allow all admin executions. Again, WDAC does not allow the admin to execute just whatever they want and has no possibility to do so. Right? One of the big differences that still exists between AppLocker and WDAC is that you cannot distinguish rules between different types of users. Right? To us, we consider that to be a good thing. Right? For app allow listing, our stance is you either trust the application or you do not trust the application. Right? Who executes the application should not have any relevant impact on that decision. Right? Either it's a decent application or it's not a decent application. Right? Who executes it? An application does not behave differently for different people. Right? So that's our default WDAC implementation. As you can see, we start from quite different places. Right? This is X8, DLL, and scripts all together. Right? AppLocker, its minimal implementation, starts from just X. Right? So that's one of the reasons why we think people say, well, AppLocker is easier. Well, yes, you're doing 1/3 of the work. Right? So either you do more work on the AppLocker side, and then AppLocker is going to be as complicated as Windows Defender Application Control, or we start disabling things on the WDAC side to meet you where you want to be, so that you can gradually implement your app allow listing. Right? So that's what we'll do next. Okay, but we do have a score here, and we have our tiny nice construction on how effective is a default WDAC implementation. Okay. And then you see the little bar goes up, everything in green is blocked, everything in red is not. Okay. So as you can see, a huge amount of threat campaigns are effectively blocked by this type of WDAC implementation. Right? We actually start the bottom slide or the bottom left is 50%. Right? We basically didn't want to show numbers below 50% because if your app allow listing does not stop at least half of the threat campaigns, you probably should try at least to meet 50%. Okay. So this particular implementation stops 93% of all threat campaigns. Right? That's why we've been so adamant about start implementing Windows Defender Application Control. This is a hugely beneficial technology that raises your security bar to a pretty extensive level. 93% of all actual campaigns out there from Defender for Endpoint are stopped by a Windows Defender Application Control implementation where you enable basically all of the rule collections, X8, DLL scripts. Okay, and now we're gonna start mimicking AppLocker with just X8s in Windows Defender Application Control. And we'll tell you each and every time, okay, when you make this decision, this is the number of threat campaigns that you open yourself to. Okay, and then it's up to each and every one to make their own informed decisions. Do I want to do this? Don't I want to do this? Right? And the balancing side of that is there's more work to be done. If you keep DLL rules, if you keep script rules, there's more work in building your policy and making sure that these things work the way they're supposed to work, while still blocking the malicious things. Next, demo. Okay, so the default WDAC implementation, WDAC actually comes with a tiny little wizard called the WDAC wizard. screen. Yeah, there I am. Right. So the WDAC wizard starts with a welcome screen where you can basically create policies, you can edit policies, and you can merge policies. That's basically it. We're going to create our initial policy. The very first thing it asks is about a policy type, okay? Because there's a multi-policy format and a single policy format. The single policy format is actually legacy technology within WDAC. The multiple policy format is the more current thing to do. So I'm going to leave everything on default and just click next. All right. Your next decision to make in a WDAC implementation is the mode for the implementation. We have default Windows, we have allow Microsoft, and we have signed and reputable mode. Right? Default Windows means I trust the Windows OS. Right? Well, I trust the Windows OS because they trust the certificates that are used to sign OS binaries. Right? And then they started to cheat a little. OS binaries, yes, but we kind of like it to be easy for people to use Office as well, because people pay us quite a bit of money to be able to use Office. So they've added Office 365. And they basically sign that as OS binaries. They do the same thing for OneDrive and Teams and Edge. So you don't have to worry about Teams, Edge, OneDrive, Windows. Oh, and they've done the same thing for the Intune management extensions. All right. So all of that is included in default Windows. Right? Then you have allow Microsoft mode. And as the name implies, that means you trust any code Microsoft ever code signs. Right? That includes things like PSExec, PSDump, a number of tools from the sysinternal suites that are unfortunately often used in malicious threat campaigns. Right? So if you enable those in those threat campaigns, they would no longer be stopped from using them. And then there's the signed and reputable mode, which basically means or roughly means if the code is code signed, it's all good. I don't care who signed it. Doesn't really matter to me. It's code signed. The code signing certificate changed up to a trusted root on my system. Yeah, thumbs up, go. The third one, you basically do not know what you're trusting. It's a bit of a black box on what you're trusting at that point in time. And malicious perpetrators to sign their code nowadays. Right? So it's a ton of things to block. Okay, so we basically start with the default Windows mode, because that's what we explained to you on the previous slides. Right. Then there's a number of policy rules. Right. We'll leave those at default. Right. There's custom rules that you can create. We're leaving those at default now as well. And we're done. We have our default WDAC policy that blocks 93% of all of the threat campaigns. Right? You might have noticed we did not do anything for program files x86 or Windows. So it blocked 93% of your threat campaigns and probably 95% of all of your business's applications. Right?
But you're very secure.
Yeah. Not necessarily the endpoint you want to be, but this is how you start off with your initial campaign. Okay, back to slide that, I believe. Yes.
So one of the things you can do to start mimicking your app locker or your default app locker setup that we've been talking about is by adding path rules in WDAC. You could create one for program files x86 and Windows if you want to do that. And it'll basically say that if I say that I trust everything in C program files and then a wildcard, everything in that folder will be allowed to run. So all the applications that are installed in that folder will be allowed to run. So you do that for program files and program files x86, because that's a pretty common thing to do and a normal thing to do. And it will help you to make those applications already trusted by default. In Windows 10, you can only have a wildcard in the beginning or at the end of your path. Having a wildcard at the beginning of a path is probably not the best thing to do. It makes more sense to have it at the end of the path and say, hey, I want everything in C, program files, wildcard, something like that. That makes sense. An interesting thing there is that if in one of the paths that you are starting to trust, there is a path that is user writable, WDAC will exclude it from the path rule. So it means that any code, that is, if you have in program files a subfolder that would be user writable, the code in there will not be allowed to run, because as an attacker, I will be able to put files in there, execute them, and they would be bypassed. So this is evaluated at runtime, meaning that if suddenly you want to execute a file, WDAC will check if that path was user writable. If it was, it will block the file from executing. If it was not user writable, it will just go on and allow you to run it. So all your applications in there, normally if you would browse to program files, you will not be allowed to go there, because you are not allowed to write there, just read there, and then it would just allow it to execute. If you are allowed to write there, it will block it from executing.
This basically eliminates the work you have to do in an app locker implementation, because app locker doesn't have that functionality. If an application installs something that has a subfolder that is user writable, you basically have to scan your implementations for that to happen on a regular basis, so that you can create explicit deny rules in your app locker implementation. If you do not do that piece of the work, you're going to end up with an app locker implementation that is basically flawed, and people are going to find that particular folder and bypass everything, because they'll just copy files in there and execute everything from there. Right? WDAC with this functionality eliminates that piece of the work for you. Right?
There is one small thing to notice, that if you would create a path rule for a folder that does not exist, me as a user, I can probably create that folder then, and I have to change permission rights on that folder. Since I created it, by default, Windows allows you to change permissions on that. So I would be able to create a folder, I have full permissions and change permissions on that, then put my stuff in there, remove my writable rights from that, and it would be allowed by AppLocker to run, although I created the folder and that was not supposed to happen. So do be careful with creating path rules for folders that do not exist yet. AppLocker has the same issue as well. Well, and the fact that they don't even check whether it's writable or not, but in this scenario, it doesn't really matter. So that's definitely something to
Your app lockers, they should not have path rules in there if you're not certain those path rules exist on all of the devices you deploy this.
Make sense? Yeah.
Does WDAC report when it detects these and blocks them? If it detects that there's a folder within C program files that a user has access to, does that get logged somewhere you can report on?
Yeah.
Because I can imagine there are all kinds of legacy applications that just grant a user or grant everyone full control to files in there that
Yeah.
you find as you roll.
Your
it out.
code integrity log will tell you, one, we blocked this. And if you know enough about the actual logs, they actually specify, and the reason we blocked it is because it was user writable. It's basically in flags and properties. It's not that they specify in text, we blocked this because the folder was user writable, but it is actually discoverable in the logs.
So with that said, we can show you how you would add path rules. You gonna show it?
Yeah, we're gonna type the numbers. Right. So do that wizard.
It's it.
It's that, it's not straight to reflection. So here's our WDAC wizard again. Find my policy. I didn't look at the back where it was stored. I'll just create a new one and try to remember where I actually saved it this time around. The next, I'm creating that same policy again. Try to remember that. Next, and I want to create a custom rule. And I basically want to create a custom rule or path rule. Select path. I select that one and create a folder rule. And I'm creating a folder rule for C to C drive. And I'll basically create two path rules for program files. Okay, so that's program files. And I'll do the same thing. I click next instead of creating the second rule. Bad on me. Oh, it takes a lot of time to create new policies. So custom rule. It's over again. Well, folder. The program files. Okay. Create rule. Go to add custom rule again. And do the same thing with the program files x86. And so we've now opened up our policy a bit more. Well, we're trying to solve that 95% of applications being blocked, right? So what is the impact on the threat campaigns when we do this? Right. So I'm creating my next path rule. No, not program data. Program files 686. Okay. Create rules. So we now have program files and program files x86 wildcard, right? Blocked. So what does that mean to our nice light tower if we open up these two folder rules? And we see the green, and a piece of red. Right. The little dot is where the previous implementation stopped. As you can see, adding program files and program files x86 in regards to stopping or not stopping threat campaigns has exactly 0 impact. There's no threat campaigns out there that abuse anything directly in program files or program files x86. Great. That means I can easily allow those rules, and I don't have to worry too much around the attack surface I'm opening up. Right?
And this does allow a lot of your applications to just go and run without you having to worry about rules or whatever.
So the 95% of applications being blocked probably went down to a single-digit percentage number, and we're still blocking all of the same threat campaigns. Good on us.
To his question earlier, does this allow
override the not allowing user writable folders? Or,
No.
okay, so if there's a user writable folder inside program files, it will
Still
still,
yeah.
okay.
That,
I'm just trying to order precedence.
yeah, so that type of application would still be in the 10% of applications that's probably blocked.
Okay.
Right. So depending on what is in that user writable folder,
Right.
if the only thing that they're writing in there are log files or things like that, your application will still function.
Okay.
And now, an app blocker implementation doesn't just have program files and program files x86. Why didn't you create all three path rules and see what happens? Okay, so we'll add another custom rule so that we basically mimic what app blocker does. Right? And we create a Windows path rule as well. So I'll create another rule type, path, folder, browse, again, towards the local C drive, C Windows. And when we say C Windows, we'll equally see the impact on our LATs. Okay. Policy done, create rule. All right. We now have C Windows wildcard allowed as well. Impact, I don't know by heart. You don't know by heart.
I do know by heart, obviously.
Okay, put the slide back up. Great. So we see the LATs going up.
What is the feeds that this light is getting from the computer?
Hmm?
What is the feeds that the light is getting from the computer?
There's no link.
Okay,
No,
It's
it's just
just
typing
doing
in
it manually. I'm just typing in the percentage.
Okay.
Visual.
Yeah, it's just to try to give you a visual representation in what the
Okay.
impact of a certain rule would be. So what you see now is that before adding Windows, you were up here at 93%.
Yeah.
Now that you suddenly allowed Windows as a part rule, your percentage drops to 90%.
Okay.
So that's what we're trying to show you, because the
Okay.
percentages, but now this is right in your face. Now you see where you are.
Anybody want to guess why this dropped? There's one that you should definitely know, where if I'm going to tell you, you're going to say, oh yeah, right.
Temp folder or?
No, because temp folders would still be blocked
Okay.
because it's user writable. That's what you're referring to. I would block that.
Because he typed in the lower number.
Yes. That's a technically accurate number.
The best kind of correct.
But there are actually threat campaigns that bypass app blocker because app blocker allows Windows. And there's a threat campaign that all of you know if I name the campaign.
Brian actually said it in his presentation.
Print Nightmare?
Print Nightmare. Print Nightmare was a threat campaign from June, July 2021 that basically abused the Windows folder to drop the TLL in the Windows folder and then do its magic. Since you're dropping it in the Windows folder, you're basically bypassing app blocker because app blocker trusts everything in the Windows folder. Whereas if you look at WDAC, WDAC works on trusting the files in the Windows folders by looking at the certificates used to sign the files in the Windows folder. So WDAC blocks Print Nightmare without you putting in any effort. App blocker requires you to come up with some sort of way to block those things in the folder that Print Nightmare used without blocking printing. Okay, so even if you had an app blocker implementation, you were still scratching your head. Oh, how are we solving this? Whereas WDAC implementation, we looked at it. Yeah, not a problem. Done. And that's the difference.
So peace of mind you get is tremendous.
And it's not just Print Nightmare. There was actually a problem with Windows drivers as well, where initially a Razer mouse was used as a driver to bypass security of an Apple outlisting thing. So there's 2 or 3 campaigns out there that actually uses or abuse the Windows folder to bypass Apple outlisting solutions. Right? We typically do not implement the Windows rule right? Because of that, and because, well, Print Nightmare, as the name suggests, is based on a vulnerability in the print spooler. If you're somewhat active in the security industry or you're somewhat security conscious, this is not the first vulnerability we have in the print spooler service. And let's say that our guess is that it probably will not be the last. Okay. There's that piece of the story. It's a small numbers of percentage. But again, trusting the Windows folder in a WDAC implementation doesn't provide me with much. Everything in the Windows folder is already trusted because it's code signed with a certificate. Right? So I don't need that particular rule. So we typically do not anyway. All right. Mimicking AppLocker in WDAC, we told you that the default WDAC implementation implements script rules, meaning all of your scripts have to be somewhat trusted as well. Right? And this goes back to Adam, and it's not just Adam. A number of people that talk to us about AppLocker is easier because they take scripts out of the equation. They don't enable the default rules for scripts. They don't enforce scripts. So it's easier. It's less work. I don't have to do all of the script work. Now, there's a couple of things when we look at script rules. Because scripts is a very broad term. We have batch scripts. We have PowerShell scripts. We have Windows shell host. We have VB script. We have Perl scripts. We have Python scripts. We have a whole ton of scripts. Okay, so to be more clear, in scripts, and this is just us inventing terminology, we have enlightened hosts, we have blocked hosts, and we have uncontrolled hosts. Okay. Enlightened hosts are PowerShell, VB scripts, C scripts, and Java scripts. That means they understand app allow listing. Meaning, when you try to run these type of scripts, the scripts will either be blocked or allowed based on what is in your app allow listing policy. App allow listing policy being AppLocker or WDAC. You'll have to make them trusted. Okay. There's blocked hosts. Okay. How many of you know MSHTA? HTML applications. Something from back in the day. Should no longer be used, typically are no longer used. But if you are using them, I have sad news for you. MSHTA is a blocked host. It doesn't understand app allow listing, and its default behavior is, I no longer allow this. And that's true when you enable script rules in AppLocker or in WDAC. MSHTA will not run. MSXML, MS stands for Microsoft, XML stands for XML. MSXML actually has a way of embedding scripts within the XML. I don't know who came up with the idea. I don't know what the use case for it was. It should not be active anymore today. If you have applications for which this is active, again, I have sad news for you. They'll no longer work. There's nothing I can do. If you use scripts, if you depend on blocked hosts, you're toast in both AppLocker and WDAC for enforcing scripts enforcement. And then there's uncontrolled hosts. cmd.exe is an uncontrolled host. I cannot block anything that is done in cmd.exe. That being said, if you do anything in cmd.exe that triggers any of the other rules, I'm obviously blocking that. If you try to launch an executable from cmd.exe, I'll block that executable. But I basically cannot block you before you actually start doing other things that block me. If you enable Python, Python is an uncontrolled host. The minute you enable Python, basically all Python scripts can run. And keep in mind, Python is about as powerful a language as PowerShell. So if you allow Python on your systems, there's not a whole lot I can do to help defend you against Python scripts. Third-party JavaScript engines, Java.exe and then Java runtimes. If you need those and you enable those, again, there's not a whole lot I can do. Custom PowerShell hosts. You can actually develop your own PowerShell host. If you develop your own PowerShell host, you're probably not going to include the security features that PowerShell 5 and PowerShell 7 have. So you'll basically bypass. And PowerShell v2 doesn't have all of the security controls that started in PowerShell 5. So if you still have PowerShell v2 on your systems, that'll probably be used to bypass your script. And so how do we disable script enforcement on? Should we first get the number up? You can first get the number up. So what happens if you disable script enforcement? There's a serious impact towards your security level if you disable script enforcement. Right. A large number of attacks out there are PowerShell based, are JavaScript based. It's not just PowerShell. Right. So a lot of knee-jerk reactions is, I want to disable PowerShell. I want to block PowerShell. Well, you don't need to block PowerShell. What you want to achieve is you want to block PowerShell for the malicious people. You want to allow your own PowerShell scripts to run. Right? That's why you implement Apple listing and include your PowerShell scripts. Again, I think we went down to 73%. 73%. Right? So actual track campaigns. This is not us making up numbers. This is us looking at what Microsoft sees in Defender for Endpoint, analyzing those and say, this is the net result. Right. So if you look at our minimal app locker implementation, where we just do exits, so no scripts, we're already down to 73%. Right. I mean, we're already a number of percentages down because we allow Windows. So
We'll have to move a bit faster.
move faster.
Yes. So to allow your PowerShell scripts to run, so unless you want to disable scripting, which is probably a bad idea. If you want to allow your own PowerShell scripts to run, you'd have to sign them. You're going to show it?
Now I'm going to show how to disable it. And you're going to, no, I cannot.
It doesn't matter. So if you want to allow your own PowerShell scripts to run, the easiest thing to do is to sign them. Code signing is hard. It's difficult. I don't want to do that. Well, it's actually not that hard. So you might want to, well, show first how to do the disable thing.
So we saw this page with the configure policy template, and we kind of skipped through it in the previous creations of our policy. There is actually a disable script enforcement. So if you want to do this, done.
Of course, one of those double negatives where you enable it to disable it.
Yeah. You enable the disablement of script enforcement.
Yes.
You're in the right building for exactly that kind of thing.
So that's basically it. The proper way of doing it is basically what Tom is going to explain.
So start signing your PowerShell scripts. And if you have an internal PKI, ask for a code signing certificate. If you don't have an internal PKI, you can buy a public code signing certificate. If you don't want to do that, you can actually create your own code signing certificate with this single line PowerShell command, which has new self-signed certificate, has to be a code signing certificate with a name, and it will go into my, because it's a user certificate, into my user store in the certificate. That's what it needs. That's what it takes to create a code signing certificate on your machine. Next would be to add it to the trusted store so that it's actually allowed for executing. And then you need to start signing your scripts with that certificate. Again, very, very difficult. You say set authentic code signature with your certificate that we dynamically get back from your certificate store. And then you basically say, I want to sign a specific file. That's it. We recommend you to add a timestamp server so that if your certificate expires, that the script will still be allowed to run if it was signed before it expired. So that's that. But that's roughly what it takes to sign a script. And you can do that for an individual file. You can do that for a folder with all the files in there. It's fairly easy thing to do. Yes.
How does that work when you're actually developing that script though, right? Like it's usually easy to like sign the script when it's all done, but I don't know about anyone else in the room, but I usually have to like build the script iteratively. So it's like, what's the process for?
Well, if your development engine is VS Code, there's plugins that every time you save,
Okay,
immediately signs it. Our typical process at customers for this is we'll create you a specific WDAC policy that trusts your particular certificate, because you're a script developer, on your particular system you're developing on. And while you're developing, that script will run on your system. You will not be allowed to distribute it throughout the organization based on that certificate. And when your script is done and you want to run it across my organization, we'll re-sign it with a certificate that is trusted across the board. That's basically the process that we.
so not PowerShell ISC, that's what you're telling me. Not PowerShell ISC, that's what you're telling me.
I think you can actually do this.
PowerShell has a plugin that automates as well.
Thank you.
Yeah.
If you're using something like remediation scripts and endpoint analytics and Intune, and it's running a PowerShell command, is that running at a way that it wouldn't get blocked, or does it still need to be, okay, still?
No, you'll have to make it trusted.
Okay,
You can
WDAC,
sign those as well.
okay.
well, WDAC will block it. App blocker, your solution will probably run as local system as admin. So if you have the admin roles, there.
Okay. Okay.
There's something really specific that Kim said too, that I think is really important to pull out of that with regards to the policy. It's this certificate on this machine. Because a certificate is as insecure as a password at the end of the day if it has a private key on it. And a code signing cert by its very nature, unless it's a hardware token certificate with an E2 attached to it, has the private key. That means that if you have code signing certs that you're issuing and you're using those to sign stuff, well, they're as insecure as just having passwords running around, unless you have something else blocking that execution.
So that's exactly the reason why we don't allow Brian's code signing certificate that he uses in development on his development system to deploy scripts across the board throughout the entire organization.
So this is just to get you started, right?
Yeah.
And
I thought that was a really interesting point and wanted to dive into the why, because I think that's an important thing to understand about certificates in general and certificate hygiene. in general.
Absolutely.
And regarding the policy rules that you mentioned, how do you roll out the specific, where you generate the processes like config manager or group policy or something, like when you have larger number of computers or Windows devices where you want to roll out, how do you do
So you
that?
get, we'll get there. It's basically on the last slide. Config manager and Intune management extension and so on have particularly interesting functionality, which we'll talk to about in the WDAC benefits to solve those type of. We'll get there. So next, mimicking app blocker in WDAC, we said we block all DLLs. Tom already said you can have wildcards at the front of a pod rule. Right? So I could create an allow wildcard.dll kind of rule. Right? It's not recommended. It's actually strongly discouraged. We do urge you to reconsider. Get the picture. This is not a good idea. It's somewhat blurry. You're not supposed to read it. You're getting the slides. What you see here is a PowerShell script that basically has a number of lines of C# code that you can basically paste your own C# code in, and that will create a DLL for you, and it'll execute that DLL with run DLL32.exe and basically bypass everything.
But if you do this, the green bar would go to the top.
No, it would go. Well, that's what we're actually gonna show, but I don't know, because the percentage here is not correct, I think. I don't know the exact percentage. For DLLs.
Yeah, no, we didn't really calculate it. We'll show it.
So bad.
Well, basically, it's bad. It's bad. It basically, we're now at the stage, if you look at what we were doing, we started off with exits, DLLs, and scripts. Without path rules. We've now created path rules. We've disabled scripts. We're now going to disable DLL. We're basically down to our app blocker exit implementation. And that's basically where we are at. Adam told us that in an app blocker implementation, he still had some applications outside of program files x86, typically in the user profile. So I asked, sure, okay, so how do you make those trusted? He said, well, we create publisher rules for this because this is Citrix junk and those types of things. We just create publisher rules for Citrix and that's done. I'll show it. And again, if you want to create publisher rules in WDAC, you can. You just create WDAC rules in the WDAC wizard for whatever application. And Tom's going to show that.
That would be next.
Yeah, it's next.
Custom rule.
Oh.
That's a quick question while he's doing that. So I work in a school and we have students in computer science and I'm thinking of Python IDE. Would the IDE for Python be blocked because it's a Python interpreter?
Python, Python is an executable, the IDE itself is an executable.
Right.
So if you do not allow that to run, it will be blocked.
Right, but if it was installed in program, because you were saying Python as a scripting was blocked, I'm just trying to figure out.
No, the IDE in program files would still run.
Right,
The Python.exit, the Python host,
right,
well, will only run if you install it and trust it. If
okay,
you install it and trust it, then you're basically creating a bypass for all Python scripts.
right. Yeah, this is, for a computer science class, I
Yeah,
gotta figure out.
it's kind of the balance.
Yeah, okay.
So to create a publisher rule, you add a custom rule, say that publisher, you browse to your executable that you want to create a rule for, and the WDAC wizard will then extract the information to create the publisher rule and say that I'll trust everything that is signed by this certificate, by certificate that is issued by Microsoft code signing certificate, and that has Microsoft Corporation in the name. Doing this allows all applications that have those same two things to run in your organization. So creating publisher rules in WDAC is as easy as it is in.
It's very similar to the app blocker interface where you basically have a slider instead of checkboxes for the individual.
And then you can make it more secure if you want to. You can tone it or turn up the key if you want to, but we're all about mimicking the app blocker implementation. But we really have to go fast because we're already over time. Okay. So that's
Next. So that's our recap. We didn't want to show the percentage of app blocker exit only with default path rules and so on. We're going to show it now. The Tom will basically type in our magical number now.
That's bad.
well, we can't actually show it.
We can't actually show it. It's pretty sad. An app blocker exit only implementation stops 37% of all the threat campaigns out there.
But we only start at 50%.
We only started at 50 because we were still doing the numbers and the math when we decided we're going to start at 50 because that seemed like a sensible thing to do. If you don't stop 50% of the campaigns, you have no passing score. 50% typically is a passing score. When we did the numbers for an entire year, we ended up with 37.
So yeah, as a recap, WDAC default 93%. If you add program file path rules, fine, 93%. If you start adding windows, you go down to 90%. If you then disable scripts, you go down to 73%. If you would allow the path rules and the scripts, so all the combination, 67%, and app blocker only, XA only, well, yeah, I'd say don't bother. That's wrong, but it's, be aware that this is the impact of what you're doing.
The 37% means you still block 37% of threat campaigns. That means you do 37% more than everybody that does nothing. But it is what it is. Okay.
Very quick. Very quick.
Very quick, the case of the WDAC bypasses, because we didn't hit the 100%, we hit 93. Two campaigns target exchange on-prem. Get rid of exchange on-prem, and I arrive at 96%. That's just the simple matter of truth of what is going on. Two campaigns target the Log4j logging framework. I don't know whether people have heard of Log4j or the vulnerabilities in it. It's been kind of a thing. We've always erred on the side of cautiousness when we looked at bypasses. So Log4j, we've marked them as bypasses because if your Log4j software runs with elevated credentials, you'll be able to disable AppLocker or WDAC at that point in time. So that's why we marked them as bypasses. If Log4j runs with limited credentials, there would not be actual bypasses. Okay, but we were very, very strict in when we consider something a bypass. One campaign used java.exe. There's an actual campaign out there that abuses you having installed java.exe and uses a malicious jar file to do its malicious thing. Right? That goes back to Python. We haven't seen actual Python campaigns. That would be the same thing. The minute you allow uncontrolled hosts, there's not a whole lot I can do for you. Right? And one campaign uses IE11 and loads it code through IE11 directly into memory. Again, easy fix. Do not have IE11. Right? So you can do additional things on top of that increase it.
So what can you do if you already have AppLocker and you want to migrate to WDAC? There is on GitHub a toolkit that takes your AppLocker policy and converts it into a WDAC policy for you. It's not without any issues, depending on how complex your AppLocker implementation is. We've seen it fail, but it does get you started. Beware of the law of conservation of misery. Depending on how well you created your AppLocker, garbage in is garbage out, right? We're just gonna take whatever you had in AppLocker and make it WDAC. But if you had pod rules in there for pods that didn't exist, that was a bad idea. So maybe you want to reevaluate the pod rules. Maybe you want to reevaluate all the publishers that you had in there. But you don't have to. It's really up to you. But those are things to consider if you're taking your current AppLocker setup and moving it over to WDAC. That being said, if you do that, there is a few things that you'll gain from migrating from AppLocker to WDAC. One is the managed installer. If you enable WDAC by using Config Manager or Intune, every application that is deployed through Intune or Config Manager will automatically be trusted due to the managed installer. So that's something that is very useful because you don't have to take the additional effort in trusting that or creating a publisher. If you deploy the application through Config Manager or Intune, it will be trusted and it will run on your machines. And since most of us are using Config Manager and Intune, that's an easy way to get you started and move forward.
And it's not just application. This goes for any file, any executable file written to disk by either of those solutions. Right? So that lowers your management of the solution by quite a bit.
WDAC has a set of recommended block rules. So there are still things that are known bypasses. They are documented. There is a website online by Microsoft that you can just copy and paste those block rules into your policy, and it will automatically block for you all those known bypasses. So that's actively maintained. If a new vulnerability bypass is found, those block rules are updated. Not automatically in your environment, but you can copy paste those over.
Which again reduces your workload in comparison with an AppLocker implementation, where you have to stay on top of, are there new AppLocker bypasses that I have to start actively blocking?
I'm going to skip the third one for a second. There's no DLL performance concern. There is no warning because DLL is already enabled by default. There is no concern in AppLocker either, as Kim explained, but there is that goes away. And it's actively being developed. We've already found a number of bugs, reported them, and they have been fixed. So it's still being worked on versus AppLocker is no longer being maintained. And The big thing here, if you look at the documentation, Microsoft says that AppLocker is a compliance feature and not a security feature, versus WDAC is a security feature. So that's something you might want to keep in mind, and that's things that WDAC do give you. I think we already explained the Windows Cloud rule, why you may or may not want to do that. It lowers the bar because there's a few known exploits. Do you really want to trust everything signed by Microsoft? Kim already explained that. What about PSXEC and so on? So that's why we opt for the more strict one, where we just say everything in Windows and not everything signed by Microsoft. But it's really up to you whether you want to do that or not. And then you want to say the final words?
Yeah, so there is work to be done if you want to implement Apple Out Listening. We're not going to tell you that this is something you do like this. There is work to be done, but as you've seen with our little bar with colors, there is a very huge return. A huge return in what you block, and even just operational wise, we all do software updates. Brian Dan talked about software updates, doing expedited software updates, because, oh my God, something's malicious is going on. We really, really need to get the update out now. You're seldomly in that position if you have Apple Out Listening implemented. Because even if there is a bug that you have to patch, and we still strongly advise you to patch, chances that a malicious campaign can actually work on your systems is heavily reduced by having Apple Out Listening.
You still have to patch though.
You still have to patch. This is not do not patch, but it does buy you time to do your patching at your own pace instead of I have to rush this out because I don't know what is going to happen from the malicious side. Yes, I know what's going to happen from the malicious side. It's a print nightmare, and I don't care about it because it's not going to work on my systems. So I don't have to rush that print nightmare patch out because I know it will not impact me.
You go from a reactive mode to a proactive mode, which is a very big shift in how you think about things. Where before having application control in place, if there's something happening out there, you will have to start investigating whether or not it will impact you. With application control in place, you don't have to do that because you know that you already block all the bad things by default.
We're redoing our WDAC training. We kind of rushed through what we could share for AppLocker. We actually have a training of 10 modules on WDAC, 2 hours per module that we do on Tuesday and Thursday evenings for us, which means for the US, it's typically beginning of your day. We've done it and 2 years ago, a year ago, we've had Brazilian people, US people, Australian people sign up. So it's a pretty international crowd, and you basically get 2 hours on every Tuesday, Thursday for 5 weeks. That's basically what we do. And as I hope we've shown you, WDAC is about as hard as you make it when compared to AppLocker, because I can mimic AppLocker quite well. Right? There's an impact to every time you try to move more to AppLocker Axiom. Right? And the question is, where do you want to stop? Right? What are your goals and where do you want to stop?
So we started by trying to assess what the impact was of each of those decisions. And well, I think with the threat campaigns and Kim's analysis, and the percentages, we were able now to show you that if you do this, keep in mind, this happens with your security. That was the whole idea. That's it.
We're done.
Thank you. Thank you.